All right. So finding the sum, this is what they want you to do. Find the sum of the first nth terms can be found using this formula, and they give you this handy little formula. We won't get too far into it other than to say make sure you write all this down in your notes. I can't stress that enough. Other than that, find the sum of the first 18 terms of the sequence, so we're multiplying by -4 to get from one term to the other. Multiply by -4, multiply by -4. And we're going to execute this formula. Now R is simply your common ratio. We know that to be -4. Our A1 is our very first term. We know that to be 2. And they want the first 18 terms. Now when I think about this number, if I'm adding them together, you'll notice each new number that comes up is significantly larger than everything that came before it. Example, -8 is much bigger than -2. Positive 32 is much bigger than -8 and -2 together. -128 is much bigger than the rest of it. So when I execute this formula, it's either going to be a very large positive number or a very large negative number, because the next number that comes up really dominates the entirety of the series. When I look at 18 terms, every other number is negative, so the even numbers are going to make the whole sum negative. The odd numbers of terms are going to make the whole sum positive. This is an 18th term, so it's going to be even. It's going to be a very large negative number. I'm going to fill out the formula. So I've got 2 as my first value. I've got 1 minus -4 to the 18th. It's going to be over 1 minus -4. Now when you drop this into your calculator, man, you can drop the whole thing just straight into the calculator. You need to be careful with your, already done it once, need to be careful with your parentheses. So I've got 2, open up the top parentheses, and I've got 1 minus -4. We're going to raise that to the 18th. So when I close it, I'm going to use this big set to keep my numerator and denominator together. I'm going to use this little set to keep that -4 with the negative. And then I use this set to keep that numerator together. So right now I've got this part. That's these two right here. I've got these two in there, and then that first one is this big one. I'm now going to divide it by 1 minus -4. Close that bottom set. Close the big set. Boom. Going to give me a huge negative number. This is negative, I'm going to round it, -2.7 times 10 to the 7th. So 7 zeros after that if you round it. Big number. Big number. All right. Now, if you have an R value that's less than 1, all right, so you got an R value that's less than 1, your geometric series is going to have a sum. What that means is if you're multiplying by a number like 1/2, like right here, these numbers get small enough to where you approach a final total. And all you really need is for these numbers, the ratio to be less than 1. Eventually, the terms get small enough that adding them to the total no longer matters. If your ratio is larger than 1, example, it's -4, these numbers they just keep getting bigger. So that sum keeps getting bigger. And it can rotate between positive and negative, but they just get bigger and bigger. There is no final total. Find the sum of the infinite series. So on this one, we look and we see if we can find the sum of all of the terms. We want to find the sum of all of the terms. We have 3. We're going to multiply it by -1/3, multiply it by -1/3, multiply it by -1/3. That's how we're getting from one to the other. And we're going to execute this formula to find out what all of the terms in the entire series are equal to. Because these numbers are going to get very, very small very, very quickly, it's going to approach a total. Because as you add little smaller and smaller pieces to it, you don't actually increase the sum because the numbers are so small that you're adding. We're going to start off with our first term, which is 3. We're going to divide by 1 minus the rate, which is -1/3. And we have 3. over 4 over 3. So we can multiply by 3 over 4. And we'll get 9 over 4. That's it. This math, if you wanted, you can take this and you're like, I don't want to do that. That just looks crazy. Fractions make me sad. You take 3, you divide by 1 minus negative 1 over 3. You will get that same number, 9 over 4, 2.25. If you want to see it as a fraction, there you go, 9 over 4. Anyway, oh my bad, I didn't show you that part. So I just dropped it straight in the calculator, ready to go, and you can pull that out yourself. That's it.